Alright, here we are with Unit 1, Topic 4, which is mostly about parallel lines and transversals. The first three are pretty much memorization problems. For 31, I've included a parallelogram to make it a little bit easier for myself. If I was a student, I'd probably draw a p-gram. There are basically four things that you need to know about a p-gram. The first thing is that opposite sides, those green lines, and these yellow lines are parallel. That's why it's called a parallelogram. The second thing you need to know is opposite sides are also congruent. So let's write that. So we need to know that opposite sides are parallel and opposite sides are congruent. Alright, and then let's go into the angle. So for example, if this is 80 degrees, then its opposite angle here also has to be 80 degrees. Okay? So we know that opposite angles are congruent. Alright, and the next thing you know is that if this is 80, then this one and this one, because the lines are parallel, and you have, these would be, I don't know, same side interior angles if you drew them out. Since this is 80, this one would have to be 100. They would have to be supplementary and add up to 180. So if this is 100, its opposite angle is 100. These consecutive angles have to be supplementary. They have to add up to 180. So consecutive angles are supplementary. That means they add up to 180. I guess the only other thing that you need to know is about the diagonal. So if you look at the diagonal, this one and this one, you can see that the first diagonal is longer than the second one. So they're not congruent, but they do cut each other in half. So the diagonals bisect each other. Alright, so quite a few things you need to remember for programs. But if you draw a picture, it should help. Alright, number 32. What property does a rectangle have? The most important thing about a rectangle is its definition. So, let's see. Okay, so there's a rectangle. By definition, it must have 4 right angles. Okay. So, property of a rectangle, 4 right angles. And the coolest thing about a rectangle is if you do look at the diagonals, they are exactly the same. Length, unlike the p-gram where this one was longer than this one. So in a rectangle, you know that the diagonals are congruent. Alright, and finally, a square. So the square has everything. It is a rhombus, it is a rectangle, and it is definitely a cube. By definition, a square, like its daddy rectangle, must have 4 right angles. And its mommy rhombus, so it must have 4 congruent sides. Okay. What else do you need to know? You probably need to know that the diagonals of a square are congruent, just like a rectangle, but they're also 90 degrees, so they're also perpendicular. Okay, so we have 4 congruent sides, 4 right angles, just like a rectangle, and then this one is the same as a rhombus. You have that, you have that the diagonals are perpendicular. You have that the diagonals are congruent to each other. And you also know that this diagonal cuts this 90 into 45 and 45. Okay? So all the angles are cut in half. So the opposite angles are bisected by the diagonal. And I think that's all that they say in the review packet answer solution. But you could go on and on about a square. There's just a lot of things about a square. All right. Okay. Number 34. Triangle DEF is isosceles with C and E being the same. Okay. So you have an isosceles triangle DEF, and angle D is the same as angle E. Okay, so usually when you have an isosceles triangle, you probably imagine this, where this is 10, this is 10, and then these base angles are the same. This is exactly the same, but sideways. So just turn your head to the right, and you can see that this side would be the same as this side. So they're just trying to trick you a little bit by rotating the triangle, but don't be fooled. So you know that EF is congruent to FD. All right? And moving on. All right, number 35. So in the figure to the right, D is the midpoint of AB. So this is in the middle of AB, so this half and this half match. E is in the midpoint of AC, so I know this half and this half match. All right, so whenever you have this, where this is in the middle and this is in the middle, DE is called the mid-segment. All right, so this right here, we know as the mid-segment of the triangle. It is half the length of BC. All right, they tell me that AD is 8, so then I know this is 8, and BC is 22. So if this is 22, then I know that this is going to be half of 22. And 22 divided by 2, half of 22 is 11. So I know that DE is 11. So I write that right away. The ratio of AB to AC, let me do that again. So the ratio from AB to AC is 2 to 3. So AC is going to be bigger, all right? 2 to 3. So AB, I know. AB is 16. And AC, I don't know. So I'm going to put an X there, all right? But I know the ratio needs to be 2 to 3. So if I look at this, I can cross multiply. So all you do is you do 16 times 3, and you get 48. And then you divide by the leftover, which is 2. So divide by 2, and you get 24. So, um, so 16 times 3 is 48 equals, this one is 2x, divide both sides by 2, and you get 24 to be x. So remember, x is AC. Okay, so from here to here, you know that this is all 24. Determine the length of EC. Okay, well that's easy. It's just half of 24, so that's 12. And DE, I already figured that out. It was half of 22, which is 11. So EC is 12, and DE is 11. And I think that's it. All right. So we have number 36. In the figure below, D is the midpoint. Okay. So again, that's in the middle. Cuts it in half. E is also in the middle, so we know for sure that this is the mid-segment of the triangle. Complete the statements using the items in the box to the right. Each item may be used more than once or none at all. Okay. So AD would be the same as DB or BD. It's the same thing. So it looks like in this box I see a BB, so maybe that's the one I'll choose. All right. AE is the same as EC, which is there. All right, the two lines that are parallel is the midsegment with the base. DE is parallel to BC. All right. AD right here equals this half BD. AE, this half, is the same as this half EC. All right. Something is 2 times something. Okay, so 2 of this one, 2 of these equal the base, which is BC. Okay, I'm still looking. BC's on the list. BE's on the list. I'm still good. All right, and G and H have the word ratio. Let's see. AB to AD. So AB to AD. Okay, so sometimes this can get a little bit confusing. I don't know if it's a 1 to 2 or a 2 to 1. So all I do is I just put in numbers. If this whole thing is 10, then I know the halves are 5, right? So AB to AD, AB would be the 10 and AD would be the 5. So 10 to 5 is the same as a 2 to 1 ratio. All right, which is here. So that's how I knew it was 2 to 1 and not this 1 to 2. All right, same thing. AE, AC, let's use my strategy. So if AE is, let's say, 6, then this half is 6, and this whole thing would be 12. So AE to AC ratio, AE would be 6 and AC would be 12. So 6 is smaller than 12, and this is a 1/2 ratio, a 1 to 2 ratio. All right, I hope that wasn't too confusing. And